Hi all, in this video we are going to see about Hadoop. Hadoop topics are Introduction to Hadoop, Hadoop nodes and daemons, Hadoop architecture, characteristics, Hadoop features and Hadoop advantages and disadvantages. First, let's see about Introduction to Hadoop and what is Hadoop. Hadoop is an open source software framework that is used for storing and processing large amounts of data in a distributed computing environment. It is designed to handle big data and is based on the MapReduce programming model, which allows for the parallel processing of large data sets. Now, what is Hadoop? An open source framework that allows distributed processing of large data sets across the cluster of humidity hardware, and the technology that empowers Yahoo, Facebook, Twitter, Walmart and others. Here, open source benefit of open source are source code is freely available and it may be redistributed and modified. For distributed processing, benefits are data is processed distributedly on multiple nodes or servers, and multiple machines processes the data independently and in cluster. Benefits of clusters are multiple machines connected together and nodes can connected via LAN. And for humidity hardware, benefits are economic and affordable machines, typically low performance hardware. Hadoop history. Here is a flowchart of Hadoop history. Components of Hadoop. Hadoop consists of three key parts. One is MapReduce, HDFS, Hadoop Distributed File System and Yarn. Yet another resource negotiator. Let's see about the explanation of these three components. MapReduce. The Hadoop MapReduce is the processing unit. Hadoop HDFS. Hadoop Distributed File System is the storage unit, and Hadoop Yarn. Yet another resource negotiator is a resource management unit. Hadoop nodes. Hadoop nodes consists of two nodes. One is master node and slave node. Here master node manages all services and operations. One master node is enough for a cluster, but having the secondary one increases scalability and high availability. The main operation master node does is running name node process that coordinates Hadoop storage operations, and slave node. This node provides required infrastructure such as CPU, memory and local disk for storing and processing data. This does all slave processes. The main is running data node process. Generally, cluster comprises at least 3 slave nodes, but cluster can be easily scaled up by adding many number of slave nodes. Hadoop daemons. Daemons means process. Hadoop daemons are a set of processes that run on Hadoop. Hadoop is a framework written in Java, so all these processes are Java processes. Apache Hadoop 2 consists of the following daemons: name node, data node, secondary name node, resource manager and name node. Here name node, secondary name node and resource manager work on master system, while the node manager and data node work on the slave machine. Name node. A name node works on the master system. The primary purpose of name node is to manage all the metadata. Metadata is the list of files stored in HDFS, that is Hadoop distributed file system. As we know, the data is stored in the form of blocks in a Hadoop cluster. So the data node on which or the location at which that block of file is stored is mentioned in metadata. All information regarding the logs of the transactions happening in a Hadoop cluster will be stored in metadata. The metadata is stored in the memory. Its features. It never stores the data that is present in the file. And as name node works on the master system should have good processing power and more RAM than slaves. Data node. Data node works on the slave system. The name node always instructs data node for storing the data. Data node is a program that runs on the slave system that serves the read and write request from the client. As the data is stored in this data node, they should process high memory to store more data. Secondary name node. Secondary name node is used for taking the hourly backup of the data. In case the Hadoop cluster fails or crashes, the secondary name node will take the hourly backup or checkpoints of that data and store this data into a file named FS image. This file then gets transferred to a new system. A new metadata is assigned to that new system and a new master is created with this metadata, and the cluster is made to run again correctly. This is the benefit of secondary name node. Major functions on secondary name node are: it groups the edit logs and FS image from name node together, and it continuously reads the metadata from the RAM of name node and writes into the hard disks. Resource manager. A resource manager is also known as the global master, daemon that works on the master system. The resource manager manages the resources for the applications that are running in a Hadoop cluster. The resource manager mainly consists of two things. One is application manager and the second one is scheduler. The node manager. The node manager works on the slaves system that manages the memory resource within the node and memory disk. Each slave node in a Hadoop cluster has a single node manager daemon running in it. It also sends this monitoring information to the resource manager. Next, we are going to see about Hadoop architecture. As we all know, Hadoop is a framework written in Java that utilizes a large cluster of humidity hardware to maintain and store big size data. Hadoop works on MapReduce programming algorithm that was introduced by Google. Today, lots of big brand companies are using Hadoop in their organization to deal with big data. Example, Facebook, Netflix, Yahoo, etc. The Hadoop architecture mainly consists of four components. They are MapReduce, HDFS, Hadoop Distributed File System, Yarn, Yet another resource negotiator and common utilities are Hadoop common. Let's see the clear explanation of Hadoop architecture components. First is MapReduce. MapReduce nothing but just like a algorithm or a data structure that is based on the Yarn framework. The major feature of MapReduce is to perform the distributed processing in parallel in a Hadoop cluster, which makes Hadoop working so fast. When you are dealing with big data, serial processing is no more of any use. MapReduce has mainly two tasks which are divided into two pass-wise. In first pass, map is utilized and in second pass, reduce is utilized. MapReduce consists of both map task and reduce task. Map task. Record reader. The purpose of record reader is to break the records. It is responsible for providing key value pass in a map function. The key is actually is its locational information and value is the data associated with it. Map. A map is nothing but a user defined function whose work is to process the tuples obtained from record reader. The map function either does not generate any key value pair or generate multiple pairs of these tuples. Next, combiner. Combiner is used for grouping the data in the map workflow. It is similar to a local reducer. The intermediate key value that are generated in the map is combined with the help of this combiner. Using a combiner is not necessary as it is optional. At last, partitioner. Partitioner is responsible for fetching key value pairs generated in the mapper passes. The partitioner generates the shards corresponding to each reducer. Hash code of each key is also fetched by this partition. Then partitioner performs its modules with the number of reducers. Next, about reduce tasks. Shuffle and sort. The task of reducer starts with this step, the process in which the mapper generates the intermediate key value and transfers them to the reducer task is known as a shuffling. Using shuffling process, the system can sort the data using its key value. Once some of the mapping tasks are done, shuffling begins. That is why it is a faster process and does not wait for the completion of the task performed by mapper. Reduce. The main function or task of the reduce is to gather the tuple generated from map and then perform some sorting or aggregation sort of process on those key value depending on its key element and last output format. Once all the operations are performed, the key value pairs are written into the file with the help of record writer, each record in a new line and a key value in a space separated manner. Next we are going to see about HDFS, that is Hadoop Distributed File System. Hadoop Distributed File System, that is HDFS, is utilized for storage permission. It is mainly designed for working on humidity hardware devices, inexpensive devices. Working on a distributed file system design. HDFS is designed in such a way that it believes more in storing the data in a large chunk of blocks rather than storing small data blocks. HDFS in Hadoop provides fault tolerance and high availability to storage layer and the other devices present in that Hadoop cluster. Data storage nodes in HDFS. A name node, that is master node, data node, that is slave node. Name node. Name node works as a master in a Hadoop cluster that guides the data node, that is slaves. Name node is mainly used for storing the metadata, that is the data about the data. A metadata can be the transaction logs that keep track of users' activity in a Hadoop cluster. Metadata can also be the name of the file, size, and the information about the location, that is block number, block IDs of data node. That name node stores to find the closest data node for the faster communication. Name node instructs the data nodes with the operation like delete, create, replicate, etc. Data node. Data nodes works as a slave data nodes or mainly utilized for storing the data in a Hadoop cluster. The number of data nodes can be from 1 to 500 or even more than that. The more number of data node, the Hadoop cluster will be able to store more data. So it is advised that the data node should have high storing capacity to store a large number of file blocks. Yarn, yet another resource negotiator. Yarn is a framework on which MapReduce works. Yarn performs two operations that are job scheduling and resource management. The purpose of job scheduler is to divide a big task into small jobs so that each job can be assigned to various slaves in a Hadoop cluster and processing can be maximized. Job scheduler also keeps track of which job is important, which job has more priority, dependency between the jobs, and all the other information like job timing, etc. And the use of resource manager is to manage all the resources that are made available for a running Hadoop cluster. Features of Yarn, that is multi-tenancy, scalability, cluster utilization, and compatibility. Hadoop Common or Hadoop Utilities. Hadoop Common or Hadoop Utilities are nothing but our Java library and Java files, or we can say the Java scripts that we need for all the other components present in a Hadoop cluster. These utilities are used by HDFS, Yarn, and MapReduce for running the cluster. Hadoop Common verify that hardware failure in a Hadoop cluster is common, so it needs to be solved automatically in software by a Hadoop framework. Next, we are going to see about Hadoop characteristics. The characteristics are open source, a distributed processing, fault tolerance, reliability, high availability, scalability, economic, and easy to use. Open source. Source code is freely available, can be redistributed, and can be modified. Distributed processing. Data is processed distributedly on cluster and multiple nodes in the cluster processes data independently. Fault tolerance. Failure of nodes are recovered automatically, and framework takes care of failure of hardware as well as tasks. Reliability. A data is stored on the cluster of machines despite machine failures, and failure of nodes does not cause data loss. High availability. A data is highly available and accessible despite hardware failure. There will be no downtime for end user application due to data. Scalability. In scalability, there are two scalability: vertical scalability and horizontal scalability. The vertical scalability, the new hardware can be added to the nodes, and in horizontal scalability, new nodes can be added on the fly. Economic. No need to purchase costly license and no need to purchase costly hardware. Open source plus humidity hardware gives economic. Easy to use. A distributed computing challenges are handled by framework, and client just need to concentrate on business logic. Data locality. Move computation to data instead of data to computation, and data is processed on the nodes where it is stored. The process of data locality is mentioned in the presentation. Next, we are going to see about features of Hadoop. Open source. Hadoop is open source, which means it is free to use. Since it is an open source project, the source code is available online for anyone to understand it or make some modifications as per their industry requirement. Highly scalable cluster. Hadoop is a highly scalable model. A large amount of data is divided into multiple inexpensive machines in a cluster which is processed parallelly. High availability is provided. Fault tolerance provides high availability in the Hadoop cluster. High availability means the availability of data on the Hadoop cluster due to fault tolerance. In case if any of the data node goes down, the same data can be retrieved from any other node where the data is replicated. The high available Hadoop cluster also has two or more than two name node, that is active name node and passive name node, and also known as standby name node. Cost effective. Hadoop is open source and uses cost effective humidity hardware which provides a cost efficient model unlike traditional relational database that require expensive hardware and high-end processor to deal with the big data. Hadoop uses data locality. The concept of data locality is used to make Hadoop processing fast. In the data locality concept, the computation logic is moved near data rather than moving the data to the computation logic. Hadoop provides flexibility. Hadoop is designed in such a way that it can deal with any kind of data set like structured, that is MySQL data, semi-structured, SQL and Johnson, unstructured, that is images and videos very efficiently. High processing speed. Hadoop's distributed processing model allows it to process large amount of data at high speeds. Machine learning capabilities. Hadoop offers machine learning capabilities through its ecosystem tools like Maout, which is a library for creating scalable machine learning applications. Secure. Hadoop provides built-in security features like authentication, authorization and encryption. At last, we are going to see about advantages and disadvantages. Advantages: cost, scalability, flexibility, speed, fault tolerance, high throughput, and minimum network traffic. Cost: Hadoop is open source and uses cost effective humidity hardware, which provides a cost efficient model, unlike traditional relational databases that require expensive hardware and high end processor to deal with big data. Scalability: Hadoop is a highly scalable model. A large amount of data is divided into multiple inexpensive machines in a cluster which is processed parallelly. The number of these machines or nodes can be increased or decreased as per the enterprise's requirements. Flexibility: Hadoop is designed in such a way that it can deal with any kind of data sets like structured, unstructured, and semi structured. This means it can easily process any kind of data independent of its structure, which makes it highly flexible. Speed: Hadoop uses a distributed file system to manage its storage, that is Hadoop distributed file system. In DFS, a large size file is broken into small size file blocks, then distributed among the nodes available in the Hadoop cluster. Fault tolerance: Hadoop uses humidity hardware which can be crashed at any moment. High throughput: Hadoop works on distributed file system where various jobs are assigned to various data node in a cluster. The bar of this data is processed parallelly in the Hadoop cluster, which produces high throughput. Minimum network traffic: in Hadoop, each task is divided into various small subtasks which is then assigned to each data node available in the Hadoop cluster. Disadvantages of Hadoops. Disadvantages are problem with small files, vulnerability, small data surroundings, security, higher processing, patch processing. Problem with small files. Hadoop can efficiently perform over a small number of files of large size. Hadoop stores the file in the form of file blocks which are from 128 MB in size to 256 MB. Vulnerability. Hadoop is a framework that is written in Java, and Java is one of the most commonly used programming languages, which makes it more insecure as it can be easily exploited by any of the cyber criminal. Low performance in small data surrounding. Hadoop is mainly designed for dealing with large data sets, so it can be efficiently utilized for the organization that are generating a massive volume of data. Lack of security. Data is everything for an organization. By default, the security feature in Hadoop is made unavailable. Higher processing. Read or write operation in Hadoop is immoderate since we are dealing with large size data that is in TB or PB. Supports only patch processing. The patch process is nothing but the processes that are running in the background and does not have any kind of interaction with the user. You have understand about Hadoop. Thank you.